So the first thing in this equation, I actually meant to have this be a -5. So that's 3x plus y equals -5. Now the directions for this one say solve the system of equations algebraically without solving for y in the second equation. So I do just want to point out from what we've done so far, it probably seems kind of natural to subtract 3x over. And then I'll get y equals -3x minus 5. If you're copying this, kind of stop now because that's not what we're going to do. And then I have 2y equals, and then I could set those two equal each other, just like the last one. But sometimes we actually have equations where we can't solve for y, which sounds kind of weird now, but it is coming up, as I said, soon. So we're going to look at a different method. So I still want to keep, I want this to be -5 here. Okay. So from here, what we can do is, because we know what y equals in this one, we can directly plug that in for the y in the other equation. So I'm just going to rewrite the 3x plus, and then over here, remember I made this a -5, so equals -5, and I'm just going to place what y equals in for the y that's right here. So now we're just going to start to solve this now that we just have an x. So I have my 2x squared, 3x minus 9x is -6x, and I'm actually going to move this 5 over. So this is -56 equals 0. So on this one, we're going to take a 2 out first because we have a GCF. We don't have to do the arc or rainbow or whatever you might call it in your class. So I'm going to take out a 2, and then this is going to factor into x minus 7, x plus 4. The 2 equals 0 is gone, the x equals 7, and then the x equals -4. So this is our kind of most common error with systems. That's a lot of work. We had a quadratic. It's kind of, if you stop here, it's kind of like that question I asked. If you watched the last video, I said, what do you want to eat and where do you want to eat? If you said, I want to eat pizza, but you never answered the where question, you've got part of the answer, but you don't have the whole answer. And that's what it is with a system. This system is asking you to find x and y. So if you stop and just find x's, you haven't really answered the two parts of the question. So that's why in those systems, and especially when we already have 2 x's, it kind of feels like we should be done and we've done enough. But if the question started with y's, we also have to find y. So I'm going to rewrite them up here. I think my linear equation looks a little easier, so I'll plug it into that. So we have 3x, so 3 times 7 plus y equals -5. And if I solve, I have 21 plus y equals -5, so I'm going to subtract 21. And I get y equals -26 right here. Looking at the next one, I have a -4 that I'm plugging in. So I have 3 times -4 plus y equals -5, and I kind of ran out of room, so I'm actually going to write that one up here. So I have 3 times -4 plus y equals -5, so that's -12 plus y equals -5. When I add the 12 over, that is going to give me y equals 7. So my two values, I have a 7, -26, and a -4, 7. Remember, though, it looks like 4 answers because I have 4 different numbers, but that's 2 answers with 2 parts each. So to summarize, in the above system, the first equation shared information with the second equation about the value of y. After solving this equation for x, that information can be passed back into one of the original equations to find y. It probably seems easier to solve for equations for y, as we said, but in the problems we do tomorrow, we won't be able to do that. So now we have a new system. It says in the following system of equations, solving for y would create fractions. So let's just look at that quickly. So if I tried to solve for y here, I would have, first I would subtract 4x. This is also something you don't have to write, you can just watch. Now, it's not impossible to work with fractions, but if we have another way, we might want to do it. So already that's kind of messy to work with. So that's not the way we're going to do this. So we can see solving for y is maybe not the easiest thing. So when we see these equations, it says in The equations are nicely lined up with x's, y's, and constants in the same locations in both equations. So my x's are here, then my y's, and then my constants. We can manipulate the equations so that they can be added together to eliminate a variable. The way we go about this is we pick one of the two variables. They're pretty even in terms of difficulty right now. For example, if I had a 3x and a negative 3x in the two equations, they'd kind of already be set up. 4 and 3, 3 and 8, they're going to take the same amount of work. So I want to make opposites, and I'm going to pick x's. So it's kind of like finding an LCD for 4 and 3 because we're looking at the x's. So that would be 12. So I'm going to make both equations into 12s for the x's, except one of them I want a positive 12, one of them I want a negative 12. They're already kind of set up for that. So I'm going to multiply the top equation by 3 because that's going to create a 12x in the top. Then I'm going to multiply the bottom one by 4 because that will create a negative 12. So basically, the reason we can do this, we can't just like willy-nilly multiply by 3 whenever we want to, but we're multiplying both sides of the equation by 3. I'm actually going to distribute, or I could write the 3 over here by the 25, but usually we just write it on the one side and understand that we're distributing through the whole thing. That's what makes it legal, because we have an equation and we can do the same thing to both sides. So I suggest this arrow method, where we're going to rewrite the equations next to it, just to stay organized. So that's 12x minus 9y equals 75 when I distribute that 3. So both sides of the equation grew by multiplying by 3. We can see both sides got bigger. So we haven't changed the equation. We've just kind of made all the numbers bigger with keeping that equality. In the second equation, same deal. So that's negative 12x plus 32y equals 40. Now, what we're going to do is the same thing to both sides, and what we're going to do is actually add those equations together on each side. So what we did to create this elimination, eliminating a variable, is we made it so that when we add these two, they're going to cancel opposites. Negative 9 plus 32 is 23. 75 plus 40 is 115. So I'm adding everything together. From there, we just have the y left, and now we can easily solve for y. And we get 5. So remember, that's part of our answer. We also need the other variable, or the x in this case. We found y first this time, so we're going to take this, and then this looks just like what we've done before. We plug it in to find the other variable. So I'm going to choose my first equation. So I have 4x minus 3 times 5 equals 25. So 4x minus 15 equals 25. If I add the 15 over, that's going to give me 25 plus 15 is 40. So divide by 4, x equals 4. Now, even though we found y first, we still want to write x first because that's how we write our ordered pairs. So the answer to this one is 4, 5. So we have one answer with two parts. So it says in the above system, both equations were multiplied by a constant so that the x terms had the same coefficient with opposite signs. So that was 12x and negative 12x. The equations were then added together to eliminate x. After solving this new equation for y, that information can be passed back into one of the original equations to find x. Now this lesson is a little shorter. I actually was kind of considering including the homework as part of the lesson, but you should probably have time if we were in class to finish up. There's just 6 more problems, and this is just review practice as we go into our last 2 lessons.